Okay, now we move into looking into closed frequent item set and maximal frequent item set. So let's start with this one, closed frequent item set. So again, same example we have. But before we go, what is closed item set? Closed item set, such an item set X is closed if none of its immediate superset has the same support as the item set X. Okay? Now we come here. By the way, the question is looking for what? Closed frequent item set, huh? So keep this in mind. The question is looking for closed frequent item set. While here now, I'm talking about only closed item set. So the idea is how you can resolve this question is as follows. First, you can find the closed item set. Then once you found them, then you look into the frequent item set. So now in order to find closed item set, I'm going to ignore minimum support. I don't care about this because closed item set has no attribute or has no mentioning of frequent. So we don't care so far. This is later. When I come to closed frequent item set, I'm going to employ or look into minimum support threshold. Okay, so now let me find closed item set. So let's find the item set first. Okay, so we have A. So same idea like what we have done earlier. We look for the one item set. We have B, we have C, we have D. Then what do we have? We have look into two item set. We can immediately generate them from here. So we have AB, we have AC, we have AD. Okay, so we keep going. Now we look into BC, then BD. Of course, we're not over yet. Then finally we have C. Now these are the two item set. Then we look into three item set. Then A cannot be merged with any of these A item sets. So we go immediately to here. So A, B, C. Sorry, we don't have C. Why suddenly C? Oh my God. Okay, we have D. Then we have E. Now let's generate two item set. We have AB. Can get AD. We can get AE. Then we keep going. BD. Then BE. Finally, DE. Now let's look into three item set. ABD. ABE. ADE. Then cannot merge with this. ABD we already have. ABE we already have. We cannot merge with B. BDE we don't have, so B, DE I believe we don't have anymore. E, ABE we already have. ADE we already have. A with E cannot merge. Now BDE we already have. We cannot merge with these. Okay, so pretty much we're done. And finally, we can have the 4-item set. We have only single one, A, B, D. Okay, great. Now we need to calculate the count, because you see support count is included here in the definition, so we need it. So let's look to A. A has appeared how many times? 3 times. B has appeared 5 times. D has appeared 4 times. E as well 4 times. A, B 1, 2, 3 times. So here 3 times. A, D 1, 2 times. AE 1, 2, also 2 times. And try to be careful when you calculate the count, because later the same answer I'm gonna use for maximal frequent, so you will see later. BD 1 time, 2, 3, 4 times. BE 1, 2, 3 times. DE 1, 2, 3. ABD 1, 2 times. ABE 1, 2 times as well. ADE 1 time. BDE 1, 2, 3 times. And finally 1 time. Now, after we generated the item sets, now we need to look if we have closed item sets. So again, in order to name such an item set closed, if none of its immediate superset has the same support as the item set. So let's start to inspect A. What are its immediate superset? So immediate superset would be this one, this one, this one. Yeah, only these are the immediate, huh? So don't tell me ABD. No need, because it says here only the immediate. Those are not immediate. Those will be generated from the 2 item set, from these, not from A immediately. Okay, now we need to look. Any of those immediate superset has the same support or support count? Yes. We have one case. So in this case, this is out. Okay, so this is out. This cannot be called closed. Okay, so now we're done with this. Okay, so let's start inspecting the second one. So the immediate superset for B would be this one, this one, this one. Any of these immediate superset hold the same support count? No. Here 5, none of these has 5. Then this is a closed item set. Okay, this is a closed item set. So let's keep going. Now we inspect D. D, immediate superset for D would be this one, and this one. Any of these immediate superset hold the same support count? Yes. We have one case here, 4 with this 4. That means this is out. Okay. Now we're done with this. Let's keep inspecting. Now for E, there's immediate superset for E, this one, and this one. Any of these hold the same support count? No. That means this is immediate. Sorry, this is closed item set. Okay, so hopefully I didn't miscalculate anything. No, actually, there's a miscalculation. Yeah, there's a miscalculation. Good, I got it early. Okay, so again, here, just there's one mistake. BE, DE, how many times DE has appeared? 1, 2, 3. Actually, it's correct. BE, 1, 2, 3, 4. Actually, this one is 4, not 3. Okay, so again, we inspect this one. We were looking into this one, this one, this one. Now we have one immediate superset which hold the same support count. That means this is out. Okay. So that's why here the support count is important. The results can change. Okay, now we're done with this. Now we start inspecting this one. What are the immediate superset for AB? Would be this one only. Any of these hold the same support count? No. Then this is a closed item set. Now we move on into this one. AD, immediate superset for AD would be this one. Any one of these hold the same support count? Yes, we have here 2, 2. Then this is not closed item set. Okay, keep going. Now we come into this one. AE would be the immediate superset 1, this one, and this one. Any one of these hold the same? Yes. No. Also, this is not closed item set. Now we keep going. Now we come into this one. I think you should have hold the idea, so you actually can go faster, but I have to speak each one of these. So PD, the immediate superset for PD would be this one and this one. Any one of these hold the same support count? No. Then this is a closed item set. So we keep going, right? So just you keep repeating the same thing. BE, BE, and BE. Any one of these hold the same support count? No. Then this is a closed item set. Now at DE, DE, this one and this one, we have one superset hold the same support count, so this is out. Right? Now we come into 3 item set. So 3 item set, all of them has the same superset. So this is quite easy. Just we eliminate the one that has the same support with the superset of ABDE. Sorry, of the superset, this one, ABDE. So immediately we can rule this out, right? I don't need to check the rest because 2, 1 different, 2, 1 different. This is 1, 1 same, 3, 1 different. And now we are left with this. So far those are closed item set. That means I have found the closed item set. But the question is about closed frequent item set. So now I left about what? Finding the one with frequent. So now the time comes for minimum support threshold. Now notice, by the way, this time is different. Minimum support threshold is 40. That means the item set must appear at least in 2 transactions. Right? Should appear in 2 transactions. And now is quite easy, straightforward. Any one of these do not fulfill the condition of minimum support threshold. All are okay except this one. Okay, so I put in different colors so you can recognize why this has been ruled out. So as a result, these are the closed item set, closed frequent item set. So closed frequent item set for this example is B, the one that we haven't crossed out, AB. Then we have BD. What else? BE, ABD, then ABE, BDE. Okay, so these are the closed frequent item set for this example. Okay, I hope the support count is correct. I think should be fine. Okay, now we move on into the last question, where we need to calculate the maximal frequent item set. Okay, so again, now we are at the last stage where we are going to work, or the last item in our outline list is working on maximal frequent item set. So without further ado, let's go and check about maximal frequent item set. But what is maximal frequent item set first? Maximal frequent item set is an item set is maximal frequent if it is frequent and none of its immediate superset is frequent. Okay, so again, that means because the definition is maximal frequent. Okay, so we don't have maximal item set, just maximal frequent item set. So the item set must be frequent. Clear. And none of its immediate superset is frequent. That means this is like the max item set we can get generated as a frequent. Okay, so maximal frequent item set. Now, since, by the way, if we check back the figure, if you remember, maximal frequent item set is partial or part of closed frequent item set. So now, since I found the closed frequent item set, my job has become very, very easy. Okay, so let's see. I'm going to work on this same one. Okay, I don't need to draw again. That's fine. But I'm gonna just use different color, at least for you. You can differentiate what I'm doing right now. So let me take the light blue. Okay, so, or let me take the orange. We didn't use orange. Okay, so now we're looking for maximal frequent item set. Okay, maximal frequent item set. Now, maximal frequent item set, again, it should be frequent. Now, all of these are frequent, right? Because we found closed frequent item set. So we don't worry about this condition. They are frequent. We are done with this. Now, the only matter is none of its immediate superset is frequent. Let's check. Let's check out. Okay, so again, the focus is only on the closed frequent item set. Okay, so let's start. Very easy. Actually, this one can be done very fast. Do we have, this is closed, right? Do we have immediate superset which is frequent? Yes, we have here, right? So that means this is cannot be maximal. We rule it out immediately. Okay, quite easy. Now we go to AB. Do we have immediate superset? Yes, and it's frequent, of course, because this is closed frequent item set, so this is also out. Now we go to BD. Do we have immediate superset? Yes, which is frequent, of course. That means this is out. See how easy? BE also we have, so this is out. Okay. Now, anything else left? Do we have immediate? How about ABD? Do we have immediate frequent, super frequent item set? No, because this was out, was infrequent. So this is fine, this is fine, this is fine. So now, to answer the last question for maximal frequent item set, we can say we got, yeah, B was out, huh? Because we had maybe, yeah. So we are left with A, B, D, A, B, E, and B. Okay, so these are the maximal frequent item set. I hope I don't have any mistake, but I mean, I did calculate count correctly for all. Okay, but you got the idea. So the idea is same. So this is for maximal frequent item set. Right? As you notice, they are part from closed frequent item set. Okay, so by that we conclude our example for this session. So we already saw how we can do or find frequent item set using brute force approach, right? And a priori principle. Then we look into closed frequent item set and maximal frequent item set. Okay, so I hope you find that this video is beneficial to you. Okay, thank you everyone. See you in another session.